So this is the first video in a series of machine learning in Python. We're going to be using the Titanic dataset, which I'll put a link to in the description of where to download it, but I've got that here. Before we get started, there's a few modules you're going to need to install if you haven't got them already. They are pandas and scikit-learn, so go install those on your environment. I'll put a link up here for how to do that. And then back in main, to look at our data first, I'm going to do import pandas as PD, and then I'm going to say df, which is our data frame, and that's pd.read csv, and then I'm going to pass in data.csv, that's our file, and to have a look at it, I'm going to do print df.head, which will print the first five rows of the data frame. So we've got a passenger ID, whether they survived or not. It's just a boolean. We've got the class they were in, whether it's first, second, or third class. We've got a person's name. We've got if they were male or female, their age, the number of children and parents on board, some ticket reference, how much they've paid for that ticket, the cabin they were in, and where they embarked from. S is Southampton, Q is Queenstown, C is Cherbourg, but that's probably not going to have much of an effect anyway on whether someone survived or not. Whether they survived or not, that's what we're going to be trying to predict. So for now, the columns we're going to use are going to redefine my data frame, and that's going to be the old data frame, and the columns we're going to use are age, because it's going to evacuate the younger ones first. We're going to have fair, we're going to have the P class, and we're going to need the survived or not. So we've got that, and I'm just going to look at that data frame again. So yeah, now we've just got the 4 columns that we chose, and there are, if I print more than just the first 20 of them, you can see that the age column has some nan values, and that's not going to be what we want, so we're going to need to replace those with the you can replace it with anything, but I'm going to use the average of all the other values that are not a nan. So I'm going to do df.fill na, and going to pass it value equals, and that's going to be a dictionary, and the key of that dictionary is the column in the data frame you want to alter, so that's going to be age, and then the value in that dictionary is what you want to replace it with. So if you just want to fill them all in with 0, you would do that, but I'm going to fill them with the average of the age column, so that would be df dot age dot dot mean. So if I print out all the values again, we still have nans, and that is because the fill na doesn't replace the data frame columns, it returns a new data frame, so we need to pass another parameter, which is in place equals true. And now if I run this again, we can see that the nan values have disappeared. There was one here, there's one a bit further down, but they all have values now, so that's good. All our data is free of not a number values. So the next thing we need to do is split this into our x and y. So our y is going to be what we want to predict, so that is the survived column, and the x is going to be all of these other 3 columns as a data frame. So to do that, I'm going to say x equals df and going to use that suggestion, but we need to take out the survived because that's what we're trying to predict. And then the y values is going to be the opposite, so that's going to be survived. With just one bracket. So we've got our x and y data, and we're going to need to keep some of this data aside for testing it to see how well our model has performed. So for that, we're going to need to split it into a training set, which is generally larger, and a test set, which is a bit smaller. And to do that, I'm going to use a scikit-learn module, and you're going to do from sklearn dot model selection import train test split. So that's the method we're going to be using, and it returns 4 things and the order and what those things are. You've got x train and then x test and then y train and then y test, and that is equal to train test split, and then you can pass in the x values you've got and then the y values, and you can define a test size. I'm going to use 0.2, so I'm going to have 80% of my data to be for training, and then I'm going to save 20% for the testing. So what that parameter does, and then you can say random state equals 42, and that's just for reproducibility, so you can get the same split of data for each time you run this. So we've got our 4 training test sets. So next thing we need is a classifier that's going to actually do the machine learning. So for that one, I'm going to, again, from sklearn dot neighbors import k neighbors classifier, because it's a classification problem. There's only survived or didn't survive. There's also a k neighbors regressor, but that's for another tutorial. So CLF classifier equals k neighbors classifier. There's lots of parameters that we can pass in here, but I'm just going to leave them all as the default for now, and then we'll come back to optimizing this in a future video. And then we've got to tell our machine learning classifier to actually do the learning. So that's clf.fit, and for that you pass in your training data, and it's x first, so x train and then y train. I'm just going to give that a run to make sure I haven't broken anything. Okay, no errors, but there is a warning, so that's just complaining about the shape of y train. So to get around that, it's a data frame, so I can call .values .ravel as it suggests down here, and then if I run that again, okay, yeah, no errors, so all of that is working so far. So we've got our classifier, it's all working, and to evaluate how well it performed, you can pass in clf.score. All classifiers have this method, so you can use it pretty much anywhere. And then for that, you want to pass it in x test, and then y test, and say score equals that, and then print score. If we give that a run, okay, we get 65%. That's not the best score in the world. We can definitely do better, but one of the reasons why is because I ignored the are they a male or a female column, but that's non-numerical data, so it's a little bit more involved to deal with that, but that's going to be the next tutorial. We've got a score of 65%, and one last thing that I want to show is that you can do clf.predict, and then you can pass in just your X test, and then you can print predictions. So just showing you can to get your predictions of any data that you maybe kept for something else, or if more data is available. They won't be in this case because Titanic happened a long time ago, but if there were to be some more data, you could do clf.predict and then pass in your test data, not your training data. Okay, so we get our score again, and then this is the all the did people survive or not from our X test. So thank you for watching. I hope you found that useful. If you have any questions, put them in the comments below and I'll do my best to answer them or make a video on them instead. Please like, share, comment, subscribe, all those things, and I will see you in the next video.